Hello, everybody. Thank you for coming to our web scraping talk tonight. For those of you who are already here, there were some technical difficulties, so we're just doing a brief restart. But tonight I'll be going over what is web scraping and how to do it using Python and Beautiful Soup. So to get started here, we'll talk about what is web scraping. Web scraping is a way of obtaining data from a website using an automated process, usually a program that you write in a common scripting language like Python, JavaScript, or similar. And it's used for a lot of different things. There's many different times when you might want to use web scrapers, but definitely not all the time. And there's some ethical concerns there that we'll talk about. Web scraping has been in the news recently since a U.S. District Court ruled just today that it is legal to scrape websites. LinkedIn was trying to prevent a company from scraping their data, but a district court ruled that LinkedIn was not able to do this and that the scraping the company was performing was legal. So to start off with, who uses web scraping? One of the biggest sources of web scraping on the internet is from search engines, who will use scrapers to collect data on the sites that they then rank and allow people to search for. They need to collect the contents of the page so that people can find pages by the text, by the information contained within it, and then they'll also use other features of the website to determine their search rankings and to provide other additional features for their users. But for most people who aren't search engines, scraping is a way to just collect data from a website, particularly ones that have data that you might be interested in, which sounds awfully similar to an API. APIs are something that you've probably heard of. Most modern companies will have an API that you can access either publicly or with their permission and an API key. You can use it for things like Spotify or GitHub. Almost every company that has data on the internet will offer an API for you to collect and use information from them without having to scrape their website. But a lot of data is also out there in ways that there's no API set up for, and that you'll want to use a web scraper to collect the data from. A lot of government websites, older websites, and archival website data is something that might need to be accessed in this way. When you're accessing data through a web scraper, it's important to consider the ethics of what you're doing and the burden that you might be placing on a website. Every time a website is scraped, it requires the same request, HTML, HTTP request, that a normal site visit would require. And so if you're scraping a website at a high volume, a high frequency, then you're going to be causing a lot of load for that server and incurring costs for the host of that website. So for that reason, if there are alternatives or ways to mitigate the cost that you're placing on the website, it's always something that you should try and do. If an API for data that you're looking to obtain does exist, it's more ethical and in most cases just easier to use the API to obtain that data. So definitely look for APIs before you jump right into web scraping. When you are web scraping, it's a good idea to set a user agent to go along with your requests so that if the host of the site that you're scraping determines that your traffic is something they want to avoid or that they want to contact you, there's an easy way for them to do that. So you can see here, this is an example of what you might want to set for a user agent so that when you're using your web scraper, the requests are tagged in that way. When you scrape data, it's a really good idea for you and for the purposes of the website itself to cache that data, to store it, and not to have to fetch it more than once, since requests to servers are much slower than accessing data that you already have. So if you are planning on scraping a website, try and persist as much of that data that's useful to you as possible so that you don't have to run the same request more than once. If you're using a scraper that recurses, that finds links and then grabs those pages too, don't let it recurse infinitely and let it recurse as little as possible while you're writing your application, determining what it needs to do, and so on, so that you don't immediately collect the entire website and then find that you'll need to do it again just to make a small tweak to your program. And finally, if you're collecting data that someone else has already made accessible, copying it is not a very useful activity. It's just a burden that you're placing on the website. It's always much more beneficial to transform data, to use data for new purposes, than it is to just more or less rip it from the website that's hosting it. One way that website hosts can specify how and if they want their site to be scraped is from the robots.txt file. There's a lot of nuance to this file and how it works, what might want to be put in it, and that kind of thing. But almost any big site will have a robots.txt. So if you go to, for example, LinkedIn or Facebook or GitHub, you'll be able to see the robots.txt. It's a publicly accessible file that'll have lots of different user agents and then the rules for those agents to follow in it. When I say rules, though, this is not something that a scraper has to abide by. These are guidelines and requests that the website is making of those agents that would try to scrape the website. Of course, if you were a bad actor trying to scrape a website and not care about the host, then these rules won't stop you. You could change your user agent to be anything, a random string, something like that, that would not be able to be stopped, which is a very malicious thing to do. And so these robots.txt serve as more of a notice to any would-be crawlers or scrapers that the website is asking that you act in a way that they are asking of you. And so this robots.txt is from LinkedIn, specifying what they are requesting the websites and scrapers find and don't find. So for example, at the top here we see that LinkedIn requests that Google doesn't scrape any of these subdomains of their website. And you can see at the top here they say that it is prohibited to use or scrape LinkedIn without the permission, and it's a violation of their terms and conditions. This is what the court case was about, because a crawler does not need to actually sign into the site. It doesn't have to agree to any terms and conditions, and so it's not bound by anything here that LinkedIn is prohibiting. And so it is technically legal for them to scrape the data from LinkedIn without their permission. However, it's definitely something that you should avoid doing at all costs to breach the terms of service of a website that you plan on using and that you are trying to support. If it's a website that has data that you want to use and benefit from, then it's always a good idea to make sure that that website's requests and desires are being upheld while you're doing so. And then one thing on the GitHub robots.txt that's interesting is that even right there, they call out specifically their API, which you can use instead of scraping the website. LinkedIn doesn't have an API, so they don't mention anything there. But if you look at GitHub's robots.txt, they provide information on how to access their API and how to use that rather than having to scrape their website. So now we're going to get into a bit of a demo on how to perform web scraping with Python. It's a pretty simple process that more or less amounts to these 3 to 4 steps, starting with retrieving the data from a page, parsing the data, optionally finding the next page that you want to parse, and then recursing, looping, and doing that all, and then storing the data that you want to or have retrieved. So to start that here, I'll go and I'll switch to my VS Code window. Can you guys see my VS Code, or do I need to switch the share here?
No. No.
All right, let me change windows here. All right, are you able to see my VS Code now?
Yes.
Perfect. All right, so this is the most very basic way you can scrape a website in Python. You have a URL you want to obtain, and you use the request from the URL lib, which is part of Python's basic standard library, and then we'll be able to request that page, get the data, and then we can decode it and print it. So let's run that. And in this terminal here, you can see the contents of the page get printed out. And so we've just obtained the basic HTML that is the backbone of the WebDev UW site. So then if we add a little bit onto this here, you can tell that this HTML is not very pretty to look at, hard to sort of figure out where it starts and ends. It's not formatted the way you might want it. And so to get it in a better format, we're going to want to parse it. And so that is where Beautiful Soup comes in. Beautiful Soup is a Python library that you will have to install using pip or conda or whatever Python package manager you choose to use. But what it does is it allows you to interact in a really powerful way with the HTML that you end up obtaining from a website. And so once you've gotten the HTML from that request, all you need to do is pass that into a Beautiful Soup object, and you'll get back a soup of the HTML, which then we can prettify and print here in our as a result of our program. And so here you can see now we've got the HTML from the WebDev UW site formatted in a nice way that we can look at and read. And for those of you who have seen our site, you can probably tell that this is far from what actually appears there. If you go to the WebDev UW site, then you'll find that there is actually a lot here that doesn't show up in the HTML page. And that is because the WebDev UW site is not a static site. It is built with React, and so this bundle.js here loads in the data once the page is rendered. And so that's one of the main limitations of web scraping nowadays, is that it's primarily useful for fetching static data that the website provides right away. And a lot of websites today are built with React that contain dynamic data, and therefore you are not going to be able to obtain a lot of data from very quickly or easily using Beautiful Soup and Python and that kind of thing. And so we'll talk about that a little bit more later, but for now we're going to switch to a different site. Oh yeah, and then here first I have a quick way to show you how to use the user agent as part of the request like we discussed. And so even if we try and set the user agent to this string here, which is the user agent string for the version of Chrome that I am running, we'll see if we run scraping 3 that we get the same result. Even if we pretend to be Chrome, it still does not render the HTML from the React code. It's still just the basic index.html that then loads the React in after. So instead, we're going to choose to scrape a static site, and we'll set a user agent string like I discussed earlier that allows sites to contact us if they would like to. And so the website that we're going to be scraping here today is one that I've scraped before. It's from the Ultimate Music Database, and it is a list of the Billboard top charts. The reason I was scraping this site was I was trying to compile a list of the one-hit wonders, the artists who had one song chart and then never again. So this was a website that I found that contained the data for the Billboard charts going all the way back to 1940, and in a static format that would be able to be scraped. Looking at it recently to prepare for this presentation, I found that there is an API now for Billboard data. And so if I was starting this project again today, I would use the API instead, since scraping a website is a lot of work and there's some burden on the website that you're performing itself that they might not have accounted for. But this project I think I did over 3 years ago at this point. And so it's a little bit dated, but as you can tell from this website, it is also fairly dated, so it matches the tone. And so what we're going to do here is I've just written a getPage function to encode some of the functionality we had here. And so what we'll do is we will go to that URL for the top charts from today, and we're going to parse the data from there. And so if we go ahead and run this, then we'll see that we get the whole HTML of the entire page, even longer than can fit in my console, rendered there. And so that makes sense. Since it's a static site, there's a lot here. If I open the console and we look at the page, we'll be able to see that there are a lot of different fields here, and that it's quite a large document here if we want to look at the entire page. And so that's why having the HTML in a format that we can parse is really useful, and that's where Beautiful Soup comes in. And so what Beautiful Soup does is it lets us do things to the soup of HTML in order to obtain data from it in a way that is going to be a lot more useful and a lot more meaningful and that we can extract and then use the data from. So what we have here is we're getting the soup the same as before, and then this time, instead of just printing the HTML document, we're going to find all of the A tags in the site, and then for all of these A tags, these links, we're going to print the href attribute of them. And so if we run scraping 5 here, then we will get a list of all of the different links that the page links to. And so the reason that we chose to find all these hrefs is that this is one of the features that a search engine will use in order to determine rankings. Search engines like Google and most search engines in general will, for part of their formula for where to put a website, use the amount of other sites that link to that site as a metric for how important a site is, how popular it might be. And so getting the list of all the links that a site links to is used by them in order to determine how popular a site is. So here we see they link to pages like AllMusic, the official charts, Billboard.com. These are all sites that would be bumped just a tiny bit up in the rankings because they got linked to by this site. And so this is a pretty simple use of just finding all of the A tags on a page. But you can get a lot more complicated. In this document, in this script, I've copied in a lot of the functionality of my One Hit Wonders project that parses the table on this page here. It goes through and then using some of the features of the website, things like this comment right before the beginning of the chart table. It identifies where to find the table on the page, and then it parses through each row of that table using a bunch of features here. So I will show you briefly some of those functionalities. So to start with, we get the soup, and then we pass it through getTable. And so then getTable uses this findAll, which we pass a function to find all of the comments on the page. And then we find the comment that says display chart table, and then find the next table element, which comes after that. And so that, in just a couple lines of code, has already brought us to the meat of the website, the part that we really care about. And so if you take a look at the code of a website that you're trying to scrape, then you can hopefully identify some distinguishing features, some simple, unique recipe that will lead you to that part of the website that you're trying to find. And so here now we have the table containing all the songs. Next we pass that table into parse table, and what that does is just finds all of the children of that table, all the table rows there, and it returns all of the non-header rows. And so this way we're able to get an array of HTML elements from the one element there. And then we pass each row, we pass all the rows into this parse rows function, and that goes through and parses each table row by taking the different cells, finding the elements within them, and then getting things like their text, and then stripping the data. And so in general, there's tons of different ways that you can interact with the elements of a website with Beautiful Soup. You can use things like find children, find next, parent, and then using different attributes, things like the ID or the classes on components to find exactly what you're looking for programmatically within the page. It's not something that's super easy to cover all of in this presentation here, but they have great documentation and in general can do almost anything with the HTML that you are looking to do. So once you've found something that you want to scrape, I would recommend looking at the documentation and matching up what you're trying to do with the functionality that Beautiful Soup provides. So ultimately, the goal of this is to find all of the top 40 songs from the chart on this page. And so if we run this, then we can see that these are the top 40 songs on the Billboard Top 200 today. I don't think it has them in an order since we're using a set in Python which doesn't have a distinct order to it. But we have the name of the song, the date that it started charting, and all of the artists of it. And so now with that data and the recursive scraping, which is part of the full project, but I don't have included here, I was able to determine the list of all of the one-hit wonder artists. And I have a link to that project at the end of my presentation here. But as you can see, with just over 100 lines of code here, we're able to obtain some somewhat difficult to obtain data about a popular music chart. And then we're able to, if we wanted to, use that data as the input to the program that we want to run. And so that's an example of a use of web scraping. And so now, to get back into our presentation, we saw the client interact with the server to retrieve the data. We saw Beautiful Soup parsing it. For those of you who have done text parsing in the past, you're probably familiar with regex, regular expressions, which are just a powerful way of searching through text. But unfortunately, they're not suited very well to searching HTML, since HTML is a class of language which is called context-free, but they don't fall within regular expressions. Regular expressions are a regular language, I should say, is a subset of context-free language, but HTML is not a regular language, and so a regular expression is not always very well suited to searching it, and especially not compared to something like Beautiful Soup, which knows how HTML works, how all of the different attributes work, and how to interact with them. And then, as we saw before, when we were trying to parse the WebDev UW site, the data not being present until the page loads is a significant barrier to us. But there are definitely tools out there that you can use to scrape and crawl through those websites. Selenium is a very popular one nowadays, used for things like web scraping, but also other tools, other important features like just testing websites, ensuring that your web applications are running as expected. So if you ever set up automated tests for your website, then you might end up using something like Selenium. And then finally, we saw how to obtain the data and store it. And we also saw how to find links on a web page. If we wanted to recursively perform this scraping, like some crawlers might do, we would just need to take all of those links that we found and pass them into our function that we use to collect the data from that page, and then do so recursively. That would give us lots of different pages of data. And so that's how I was able to obtain the data for the charts going back into 1940 by finding the link to the chart from the previous week and doing that to obtain the data from every single week of the Billboard charts. And so then once you have all that data, then you want to store that data and use it. And so what you probably will want to do is set up a script to obtain the data and parse it, and then store that in a format that you can interact with easily, like JSON or XML or something like that, and then write another script which then uses that data so that you avoid having to scrape the same data multiple times. I'll tell you that when I ran my One-Hit Wonders web scraper on the Billboard charts going back to 1940, I think it took a little over 4 hours to complete, just getting one page at a time, which of course you can speed up with things like multi-threading and parallelization, but in general, it's a lot easier to have the data than to have to retrieve it. So definitely make sure you're storing it. So some of the big takeaways from web scrapers and how they work for web developers, even if you don't plan on using web scrapers, are how search engines interact with your website. So there's a whole field of search engine optimization that is really important to consider if you're hoping to get your website anywhere near the first page of a search engine like Google. Especially if your website is dynamic, it doesn't have any static data on it. There are some techniques that you'll want to be employing in order to make sure that your website has an accurate description, an accurate title, and list of data about it that the search engine can use to drive users to your site and in turn put you near the top of their ranking. If your website is one that you anticipate being scraped, be it because you have data on there that might be useful to other people or something like that, you should consider putting up a robots.txt to request the way that you would like your website to be scraped. But probably even more useful would be to set up an API that would allow users to use your data or use your endpoints in order to access your data without having to scrape your website at all. And that topic setting up an API, how to use it, how to interact with it for your benefit and for others, is going to be the topic of a talk that our Vice President Ryan will be giving next week. So look forward to the announcement on that. Ryan is very passionate about APIs, and I think is going to do a great job on explaining how to set those up and how to use those. And so that has been the introduction to web scraping. I have a few links here for things like the court case that we talked about, as well as ethics, robots.txt, the documentation on Beautiful Soup, and a link to my repo for my One Hit Wonders project. So I'll send a link to this presentation out after, and everybody will be able to review the slides, click on these links, and learn more about web scraping from there. So thank you, everybody, for coming to our talk this evening. Does anybody have any questions? All right, awesome. Well, again, thank you, everybody, for coming. Look forward to hearing about Ryan's API talk next week. I think that's going to be very useful for the way that websites are designed nowadays, having the front end and the back end to them. And again, thanks for coming out.